this is number 71, and it's on page 192. And the question is worded as follows, and I will draw this out, like I say. We have a bullet which is fired, and it becomes embedded in a block of wood which is placed on a surface in front of the gun. So here we have a table, and there's a block on that table. There's a gun which is fired, and the bullet will fire and get stuck in that block, and the block's going to slide across this surface which has a coefficient of friction of 0.25, and the block has a mass of 1.35 kilograms. The bullet is 25 grams, which right away I'll convert to 0.025, 3 units, kilograms. And it tells me that the combination after it gets struck slides a distance of 9.5 meters before coming to rest. And the question is what's the muzzle speed of the bullet? In other words, what is VA equal to? Now, these problems are multiple stage problems. We can recognize a multiple stage problem by realizing that we have different types of physics going on. We have a collision here, which is a momentum problem, where we have a bullet that is striking this object. This object is at rest. In this collision, they become stuck together. And there's going to be a velocity right after that collision takes place. That velocity, initial velocity, is going to be used to determine how far this is going to be, well, will determine how far that block is going to slide along the table. So we've been told it's going to slide this far. That distance with this coefficient of friction necessitates a particular velocity of that bullet when it strikes. Now I can't just say the velocity of the bullet ends up being the velocity of the combination, because I'm sure, as you would agree, if a mosquito is flying at you at 50 meters per second, fast mosquito, you'll feel it, but it's going to splat. I mean, it's just going to hit you and turn into nothing. So a bullet in this case hitting a larger object has a similar effect. It doesn't just splat, it'll change its form, and when it hits this object, but when they become embedded together, it's going to slow it down. That block will not be sliding the velocity that the bullet strikes it at. So that's all the physics involved. Now, the very simplest way of approaching this is to recognize that we have a momentum problem and a kinematics problem. And we would like to find out what that velocity is. So we start with an equation that has in it what we want to find. And that's going to be a collision. So we have the conservation of momentum. And we go through the series of questions that we ask ourselves with the consideration of conservation of momentum. Is this a two-dimensional problem, a one-dimensional problem? It is a one-dimensional problem. You are to assume, therefore, that the bullet that hits this block hits at its center of mass. Therefore, there's no rotation of the block. It just slides straight along the table. There's no force of the bullet downwards on an angle into the block to push it into the table and have it kind of bounce up. It's not an upwards angle to cause it to pick up off the table. It's directly horizontal, hitting right at the center of mass, causing this block to not rotate at all, but just to move to the side. Not extremely realistic, but this is the condition we'd have to arrange so that we can do this in Physics 12. So the initial momentum, we have the block and we have a bullet. afterwards they're combined. So I can just state them as a combination by giving it a prime. I know that this momentum here is equal to 0, so I may as well just right now say this term is equal to 0, and I end up getting mass A times velocity A equals the mass total, mass A plus mass B, times the velocity of the combination. I know what these values are. I don't know what that is, and I don't know what that is. Fortunately, we have enough information to gather this, and then we can backtrack to that. So we have two unknowns. So mathematically, when we see this, we have two unknowns. We need two equations. If I can find another equation with either VA or V prime in it, then I'll solve it. And then I can back into here. Now, it's going to be V prime. I'll just tell you that right now. If we look at this now, the combination of the two, this velocity is going to slide 9.5 meters. So let's look at that with kinematics. Kinematics, entering into our method of solving problems using kinematics, we have a distance. We list our variables like we do really in any time we're solving any problem in physics. We have a coefficient of friction. Uh-oh, that's not kinematics. And we have a V prime, which I don't know. And so now I've got myself into a situation where, and I have an acceleration, which I don't know. I have an initial velocity, which is given by that combination, and it pulls to a stop. So maybe I should state that I'm going to let V prime equal V naught, and then V final equals 0. And I'm suspecting I'll be able to find out something about A because I'm given a coefficient of friction. The coefficient of friction allows me access to talking about the force of friction. Now, this is a dynamics problem, so now I'm going to enter into my thoughts about dynamics. Because I don't have enough information here to solve. There's no equation that will allow me to solve this at this point, so I need another equation. So now I'm going to go into force dynamics and I look at it and I have a block which is moving along. So now this is dynamics. And I don't feel like I've found my way through this problem right now, and neither should you. Rather, you should recognize that solving it by momentum didn't work. Had too many unknowns. One equation, two unknowns. So I went to kinematics because I could recognize some kinematics in the problem. And I came to the same conclusion. I don't have enough information to solve. So now I go to dynamics. And at any time, if I can solve a problem that allows me to solve for V prime, I'll solve it. Then I can get back to this and solve for my VA. So now with dynamics, I've got a block which has a bullet embedded in it. I've got Fg, I've got a normal force Fn, and I've got the force of friction acting back. So dynamics-wise, I have the equation with motion, sum of the forces in the plane with motion equals mass times acceleration. There's the A I'm looking for. Force of friction equals mass times acceleration. And the force of friction equals mu Fn, which equals mass times acceleration. And now I need to know what Fn is. Going to the other dimension, the without motion dimension, sum of the forces without motion, in this case equals 0, and I get Fn minus Fg equals 0, Fn equals Fg, Fn equals mg. And now I take this mg and I substitute it in over here. So I get mu times mg equals ma. I see the masses cancel, and now I know what my acceleration is. My acceleration equals mu times g. So I've got something. Now I can take this value back up and plug it in right there. And now I don't know this, but I do know there's an equation that relates all these three together. Namely, V final squared equals V naught squared plus 2AD. I know what this is, I know what this is, I know this is equal to 0. Now I can find V naught. My V naught equals my V prime. My V prime can be put in right here, and then I can find out what my initial velocity of the bullet was. So I won't go through all that right now. You don't need to see me crunching numbers. But what you do need to recognize here is that the art of solving problems is to keep looking for the solution. And we have these kind of milestones that let us know if we have to keep moving before we recognize what we're looking for. So we began by analyzing the question, identifying the physics involved. There's a momentum problem, and then there was a kinematics problem, but it turned out to be a dynamics problem also. And maybe some of you recognize that right away when I wrote that down. So I wrote down, you'll notice each of them. Here's my momentum, which I came to a dead end with. Here's my kinematics, which I initially came to a dead end with as well. And then here's my dynamics, which I was able to solve everything there. Now that I had all those answers, I could take those answers back to solve, first of all, kinematics, and then take the answers from kinematics to go back and solve the momentum problem, which had in it the desired variable.